Today we're going to talk about data, decision models, and problem solving, part of BAS 120 lesson number 2, which we may split into 2 videos because there's a lot to cover here. Some of the things that we'll be covering is defining what a metric is, 4 different groups of data types, concept of a decision model, how to do influence diagrams, how to compute a model, the difference between uncertainty and risk, some of the terms optimization, objective function, and optimal solution, and explain the difference between deterministic and stochastic decision models, and learn a little bit about the steps in the problem-solving process and a couple of linear break-even and make-buy decisions. So first, let's talk about data and data sets. Data and data sets are only collections of data. When we put them into a database, we're basically collecting relevant data. In some naming conventions, we name these different element attributes, fields or attributes like customer name, customer number, invoice number. In the actual records or entities or measures are called entities or records, like Johnson 110. So these are the entities or records, and these are the fields or the attributes. Now, a metric is anything that is a measurement that provides us some sort of quantifies the performance. Like, for example, the score in a game, a business's revenues or earnings, quality metrics like defects per million. And the measurement is the actual act of obtaining the data with the associated metrics. So we have metrics, and we measure those metrics. Now we have 2 types of metrics. A metric can be what's called a discrete metric. Basically, it's a yes or no, and they can be counted like on-time delivery, whether it passes inspection or not. Or it can be what's called a continuous metric, which is based on a continuous scale of measure like dollars or time or weight or something like that. Now, there's 4 types of data. The classification is hierarchical, meaning that each level includes all the information contained in the previous classification. So the classifications, and this will become a little more clear on the next chart, are categorical. That's where ordinal, interval, or ratio. So let's explain each one of these. So here are the 4 types. So a categorical is something like eye color, geographic region, employee classification, where there are different categories of them, but they're not ordered in any particular way. For example, green isn't ordered ahead of blue eye color, etc. And the reason this becomes important to us is as we start to apply different statistics, some of these mean something for data types. Some of them don't mean anything for certain data types. For example, it wouldn't really make a lot of sense to take an average of a categorical type item. Like, we couldn't really say the average eye color of a person in the United States is, I don't know what it would mean. We could do a frequency distribution. We could say what the mode is, the most frequent eye color, but it wouldn't be meaningful to do an average. Ordinal is where we take it one step further. We've got all the characteristics of a categorical, but now we've added order or ranking, like college football rankings or hospital pain rankings. The only issue is there's not necessarily an even interval between the first to the second and the second to the third. So, there might be a big gap between the number 1 team to the number 2 team, and then the number 2 team and number 3 team are very close. So that's ordinal. Then interval takes all the characteristics of ordinal, but adds a consistent difference between each interval. So like time or temperature, right? So time, from 1 to 2 is the same distance from 2 to 3. The only thing we don't have with interval information is we don't have any common zero, so we can't compare the 2 numbers. So I can't say, for example, 2 in the afternoon is twice as late as 1 in the afternoon, because I don't know where we're starting from. We have no zero. And that takes us to the last category, ratio, where you have all the prior characteristics, but you have a zero. So I can say if you sell $200 and I sell $100, because I know we're starting from a base of zero, I can now do ratio analysis and say you sold twice as much as I sold. I can't say that with time. I can't say 2 o'clock is twice as large as 1 o'clock. Hopefully that makes clear all the different data types. And the higher we go in the data type, the more statistical tools become meaningful to us. So let's have you take a little attempt at this example. In the example below, I've classified, try to classify each one of these data types as whether it's categorical, ordinal, interval, or ratio. Go ahead and I'll be back in a few seconds. Okay, here's the first one's categorical. Johnson, there's no order to the customer names. Customer numbers, there's some order, so it's ordinal, but there's nothing that says the distance between each one is the same. Same thing with invoice number. Now the dollar amount, anytime we're dealing with dollars, it's almost always ratio because I have a natural zero and I can compare. The product type is categorical. And the date would be interval. Again, it's time. The distance between each measurement is consistent and the same, but I have no natural zero, so I can't compare. Hopefully these make sense to you. And we'll move on to now how are we going to take all these different types of data and put them into some sort of logical decision model, because once I have a decision model, now I can let math and other stuff help us decide stuff. A couple forms of models, you could have them as a verbal description. You could say sales have increased over the last 10 months. You could graph, or most likely you're going to put them into some sort of mathematical model. So for example, total cost could equal my fixed cost plus my variable cost. Then I could define total cost as equal to 500 of fixed cost plus $25 for the cost of each unit. So it would be 25 times X, with X being whatever number of units I produced. And there we have a mathematical model. So now we can calculate total cost at any unit production level. Decision models tend to come with three types of inputs. There's data that's constant. There's data that's uncontrolled, like inflation rate and other things. And there's variables that we can control, like our staffing levels. So the basic model is going to be inputs, a combination of data, uncontrolled variables, and controlled variables. We'll put it into some sort of decision model or function, and we'll get some sort of output or answer. So just a checklist, take a look at this model of total cost equals variable cost, unit variable cost times quantity produced plus fixed cost. And check these questions out. As fixed costs increase, what happens to total costs? If unit variable costs were reduced, but the quantity produced stayed the same, what would happen to total costs? And if total costs were equal to, what would total costs equal if the variable costs were 5, the quantity produced were 100, and the fixed costs were 50? So take a second, and you should be able to, by looking at this function, figure these out. Okay, here was our model. Certainly if fixed cost increased, in other words this number, because there's a plus sign here, if fixed cost goes up, our function, our total costs are going to go up. If unit variable costs go up or were decreased, if this number became lower, and this stayed flat, then obviously this number would be lower and our overall function would go down. So if we reduce our unit variable costs, our total costs would go down. And then the other is just plugging in the different numbers that they gave us into this function or equation, and we get 550. That's the first half of this lesson. We'll be back with the second half.